Hello, welcome to Decidedly Retro. I'm Steve, and on today's video I'm going to be looking at creating a floppy disk interface for the Enterprise 64. You may have seen a week or so ago a quick unboxing video that where the sound didn't work properly. Anyway, all I've done since then is to create a new joystick handle, 3D designed and 3D printed and painted. Designed, 3D printed and painted a cartridge case and installed a ROM cartridge in there. I've put the disk interface ROM into this, and fits quite nicely. The disk interface I've got the schematic here. May or may not be able to see it, and effectively this is over-engineered for what I need, and so I'm going to leave out most of the power circuitry because that's designed, it's got a buck regulator built into it which takes the 9 volts which comes out of the expansion port and creates the 5 volts, but it's designed to create a lot of amps, which I don't need because I'm not going to be powering a load of floppies off there. The design has an expansion port, so I won't be having all those cards on there either, so I don't need that. So I can just fit a Traco 1 amp regulator. I'm not going to use some of the expansion port stuff, as I said, so I don't need that circuitry, and I'm only going to be using a Gotek, so I don't need the circuitry to access the 2 extra floppy drives. So anyway, as you can see, lots of things crossed out. And yes, well, let's go over to the bench camera. The first thing I need to do is to fit some wires onto the Traco, because basically the circuit board doesn't have a place for the 3-pin regulator. So what I'm going to do is glue it on here and then make wires to ground the 9 volts and 5 volts, which I can pick up on here. So yeah, that's what I'm planning to do. So let's get on with it. So here's the Traco. I've already tinned 3 wires. I know that ground is the center wire, so I can fit that first. Just re-tin that. Make sure it's printed. You've got plenty of solder. And that's that one. Now the Traco pin 1, it's the same as a normal regulator that you get in the Spectrum. So I'm just going to have to check. So input is pin 1. So that'll be yeah. And you're going to use white for the 9 volts. and red to 5 volts. Right, at this point, you need to get out the heat shrink. Right, what size do I need? Let's go over there. No, next size up. Actually, let's cut that down a bit. Don't need that long. Into 3, that should do. One, 2, 3. Put that away. Get some hot air. This is only at 150 degrees C, so it won't melt anything on any of the plastic. Let's flip that over. We'll melt the blue tack a little bit though. Right, that's safe. Now, as I say, I think what I'm going to do is actually glue it around about here with some hot glue. Take the 9 volts out over to here where the feed comes in. The ground can go almost directly below to the pad here, and the 5 volts can go around and into where the connector for the power for the floppy would usually be, but that's just needs to be about there, and then that should give the proper 5 volt power to the board. And anyway, let's get on with that. So let's get the hot glue gun out. This is quite an old hot glue gun. It's not very good. I'll put it on the back of here because then that's probably easier. It's going to take a while to warm up. You might have noticed that I had to make a longer edge connector by getting some edge connectors from Amazon, but unfortunately they are a little short, and they also have ends on the end which don't fit inside the Enterprise. So cutting those off and cutting one down, I put it together using PCB to align it, and lots of filing to get exactly the right width. before putting it together on a PCB, as I say, and using an old soldering iron to weld the plastic across. It's not come out too bad, and yeah, that should work. Right, do we have glue? Yeah, we do. Right, let's put a blob on there and take the board and glue it on there like that, I think. Right, don't need that anymore. Let's put it away. Okay, let's see about the 5 volts first. So let's close down and trace the wire around to about there. Cut, strip, and tin. Right, let's see about getting this into here. Actually, I might use these holes for the ground as well. There's that one. Bring that around. And just about there. Strip. Tin. Put through the hole. Hopefully that will do. And now we need to pick up the power from the edge connector. And according to this, power is the top of these, so I think let's put this into oops, I can't see it. Let's put that to continuity mode. I think that is going to there. Yep, so that's where I need to pick up the power. So just bring that around here, snip, strip, tin. Put this through there now. and solder. Oops, that push through. Okay. Trim the excess off. Put these wires away. Now set up the enterprise to check the voltages. Right, you should be able to see the voltmeter there. Let's switch on. Hopefully it's not isn't the wrong way around and I've fried the thing. So let's check. There we are, 10. That's actually 10 volts. And that is exactly 5 volts. Good. We have power. So that should be 5 volts there, 0 volts there, 5 volts there, 0 volts there. Good. We have proper power. Now it's a case of getting all these sockets onto the board. I'll do the sockets first because it's easier than to do that and then just poke the capacitors through there. I can also do the jumpers here. I don't need any of these jumpers because I'm not going to be installing the ROM. But I need that one, that one, that one, that one, that one, and that one. And then some resistors and capacitor and these jumpers here. Though technically I could just wire those up. So let's go with the gal first, which is the one with the extra pins. Right, let's get some blue tack. Actually, I'll do this one first. Now I can do the extension afterwards. Well, that's the first part. And let's get. I know I said previously that it was a 4-pin socket. It's actually an 8-pin socket, and I've removed 4 off. Four of the pins. Right. This is slightly more tricky. That looks okay. I still have room to push the capacitor through, legs through there, get them soldered on the other side, so that's fine. Right, now the floppy disk controller socket. That's quite easy because it's just a normal 20 amp socket. Okay. Next I'll do these three. One more socket. That's the right way around because yeah, that notch is correct. This one's the opposite way around. Right, that's all the sockets on. So now I think I'll get these jumpers, and to do that I need some sacrificial jumpers and some jumper strips. Okay. So I need 3 sets of 3. So 1, 2, 3. Oh, sorry, 2 sets of 3. There. Actually, what I might do first, because they're so close to that, I might put that in. Notice pin 1 is here. On here, pin 1 is marked by an arrow. If I can get it to focus. Of course I can't get it to focus. Oh, there you are. You can just about see it there. And what I've got to do is try to push that over as far that way as possible. So that it frees up space for the jumpers. Right, should be done. That's given enough space there for the jumper blocks. So what I'm going to do is push these in here. Bit tricky. And then to keep them in the right place, I'm going to put 2 jumpers at either end, because then that makes them into essentially a single block. I can now just solder. I'll try and wedge some blue tack in there. And just like a socket now, I can solder the diagonals. Press down, make sure it's flat, and solder the rest of the pins. That's one done. Solder the other pins. And there we are. Right, let's do the bypass caps, or rather decoupling caps. Right. These are only here to basically filter out the spikes generated by the chips switching internally. So a lot of old designs didn't actually bother to fit them, and just hoped for the best that there wasn't enough noise on the power rails to upset things. But anyway, not that important that they sit flat. So just bend the pins out. That's those ones. Right, next. One down here. Just bend the legs out a bit. This tricky one at the bottom of the dowel socket. It's not that tricky. It's through quite easily actually. I need one more, which of course means opening a new packet. that is, where is it? Ah, that C3. Right, let's check. Oh no. Doesn't look as though this chip has got a decoupling cap. No, that's not a decoupling cap. So I'll put this away. So the final thing now is to get these resistors in. But I've just noticed a problem with R5 in that this is overlapping. I might be able to get that down there, but we'll see. I need 1.5k if I can find one quickly. So I will need a 10k. There we go. 1k5. Thankfully they've got very thin leads, so I should be able to poke it down there. Can you see? Just under here. Should be able to poke that through. Hopefully. There we go. Going to cause problems for R8. I'm going to have to push that really far in so as to not bridge. Actually, if I I'm going to have to check it later, but let's try. Right. I have to do something similar to R8 so that the leads don't touch. Okay, right, I should be able to get R6 in now. Yeah, better position. Underneath R8, down the board. Not neat. Focus. I think it will work. Right, let's get the other two in there. Hopefully the 10k resistor will fit, because that looks as though it's got thicker leads. These resistors are very close together. That's not good. Right, R9, 10k resistor. Will it fit? Yeah, can just about get them through. Come on, go in. You will, you will, you will, you will, you will, you will, you will. I have to do. Now, better check for shorts on those connections. Doesn't matter at this end because this is all joined to the same, but I need to make sure I'm not shorting between these pins, and I'm not. Good. And other than fitting the chips, I think that's about it. As I say, I don't need the ROM socket, or because I've got it into the ROM cartridge, and this jumper set is purely for the ROM. I don't need that because I'm not going to be using 4 drives. Oh, there's one more thing to fit, which is the bulk capacitance capacitor, which is 100 microfarad. Just bend these out a bit so it stays in. That should be enough. Right, let's clean that up. See if we can get this. There we go. And that's quite nice and neat. So yes, now I've just got to wait for the chips to arrive. The chips have arrived, so I fitted all of the NS logic and the VL 1772 controller, floppy disk controller. Just trying to get in so you can see it properly. And it just needs the GAL now. So got a set of, come on, focus. Oh, anyway, you probably can't read the writing on there. And anyway, these are Atmel ATF 22V10C chips, and all I've got to do is now program them. Right, let's take this and program it. First we put it into the T46. Right, let's open the JED file. Won't encrypt the chip. Program, make sure the lock bit is turned off, because in case we want to reuse it for some other project. And program. And there we go. So here's the chip. Make sure we get it the right way around. So the pin one's that way. And place it in here. Now what I've got to do is see if it works. I've got a Gotex set up here already, cable here, and everything's ready, so all I need to do is set up the machine and then try it out. So as if by magic, everything's here ready to plug this in. So to the side, make sure that the PCB is fully lined up, plug in the floppy cable and move that over here a bit so you can see it. And let's switch on. Does it still work? Can't see anything on the display yet. It's preset. This is switched on. Turn on the Gotex. Right, it is at least working. Booting. Now let's see. Oh, it's reading the virtual floppy interface. Let's do a quick test. So let's save test.bas. Invalid file name. Save. There we go. And yay! So let's see if we can. I've got some. Should have some games on here. Okay. And it's working. What we got here? I'm guessing a lot of these are actually just ported Spectrum games. Minimally ported that. Okay, so what's Abyss? Press any key, okay. Well, that's very colourful. Not sure what I'm supposed to be doing. Oh, it's crashed. Anyway, the important thing is the floppy disk is working. So what I need to do now is design and print a case for that, because it's a bit floppy at the moment, and yeah, it needs precise alignment. But anyway, I'll get back to you after I've done that and we can have a look. Well, it's been a couple of weeks since the last part of the video, and I've been creating the case for the floppy disk interface and putting a GoTech on the top. These are a couple of the prototypes. This is the top case. The floppy disk stroke GoTech hat, as I call it, or floppy hat. Essentially, if I can get it right, just sits on top of the case, hiding it and allowing enough space at the back for the cables. Let's do that. So if you can see, there's enough space at the back that the cable can come out of here and go into the back of the GoTech with all the twists and stuff needed. Because unfortunately, the way that the GoTech and the interface have their ribbon cable connections is the opposite way around, so it needs a twist, double twist, just to get it to go the correct way. Anyway, those are the prototypes. They could go in the bin. And this is the final one. As you can see, cables just loop back in the back there. I've got screws here and here to hold the hat on, and the case itself is screwed in at the bottom. I did the designs in Fusion 360, and they're all on Thingiverse if you want to replicate this. Anyway, this just plugs in the side. I'll turn the computer off first, of course. Just plugs inside here, and we switch on. Hopefully that will. Oh, there is a slight problem of if you don't quite pull it forward enough, the edge connectors it doesn't line up properly. Do we have it? Yep, there we go. The light has come on. We have now the Enterprise boot screen. Return. It now looks at the floppy drive, and it's loaded the program that's called Start on the disk, on the virtual disk. In this case, it's a program loader for loading games. Anyway, let's go and see if we can find a game to play. I've not really had a look at most of these. Let's go back a few. Yes, let's go to here, and we can have, let's say, Rick Dangerous, shall we? Or yeah, or Sorcerer. Sorcery. Let's go to Sorcery. This is actually a conversion, a quick conversion of an Amstrad title. Most of the games that you can find on the Enterprise these days are conversions of the Spectrum games, because the graphics chip in here is very versatile and is easily programmed, so it can essentially be very similar to the Spectrum or the Amstrad in terms of graphics formats. So if we load this up, hopefully it'll load. There we go. It's flash loading. Been cracked, of course, so you can put cheats, but I'm just going to go straight away through. The stereo output to the screen is quite quiet, and the sound from the internal speaker, mono speaker, is quite loud relatively. So you get an interesting echo there, but otherwise it's working fine. And let's see if I can actually play the game. So, oh, there's a sword there. Yep. Oh, no. Ah, rook. Okay, good. Not sure what I'm supposed to be doing or how to work it at all. I'm probably going to die very quickly. Oh, let's just run away, run away. There's a key there. Oh. Oh, run away. Not sure what I'm supposed to be doing. Oh, oh, I died. Oh, I've scored a whole 8,500. Okay, let's that was the delete. Right, okay. Well, you can see I did actually try once before. Anyway, I think that's the end of the project, and well, see you on the next video. If you'd like to do all the YouTube-y stuff of like, subscribe, and all that sort of stuff, that would probably help other people see the video. But otherwise, have a nice day, and yeah, see you soon.